Okay, welcome back. Now, today what I want to look at is mathematics GCSE stage 4. Okay, and I'm looking at an open learning program. Now, what I want to do is to make sure that you are mathematically equipped to deal with the mathematical requirements in regards to electrical installation or even electronics or any other subjects that you wish or trade or profession that you wish to undertake. Now, mathematics plays a very important part in every part of your life or in any career that you choose to follow. Okay? And that is what I'm trying to establish here, that you use the foundation and we lay a foundation upon which you can build from to your own requirements. Okay? So, mathematics, GCSE, Key Stage 4, open learning. Now, I have to admit that I got this information from many moons ago when we were doing open learning at various colleges. Sorry, I should say I was doing open learning at various colleges, and they showed us, provided a lot of materials which was quite useful at the time. Now you won't find this material today because it's since passed on, right? But what I want to do is now let's look at that, okay? And I paid due respects to Wakefield College many moons ago, okay? Now this is the contents of what we are going to be looking at. Let me just make sure that we can get it, of course, and in full view. What we're going to be looking at is decimals, changing decimals into fractions, changing fractions into decimals, multiplication and division of decimals by powers of 10, use of calculators for decimals, problems involving decimals, accuracy, decimal places, significant figures, estimating answers, okay, and order of working. Let me just reduce that a little bit so we can make sure that it fits onto our screen. Okay, now zoom in for you so we can see that we have all the information that we need as to what we're going to do in regards to our objectives and our aims. Okay. Right, now what we're going to look at here is decimals. Ignore that, that's purely point of reference for 82.6, okay? Ignore that, but that is our heading, decimals, okay? Ignore this bit, that's not relevant to anything. And again, we're looking at mathematics GCSE Key Stage 4. Now here we have a whole number, okay? 100. These are whole numbers, 100, 10, and 1. So when we look at this here, we're looking at 150. That means 150. But now we're going to put a decimal point because we want to bring in a fraction or a decimal point or parts of a given number. So here we have 150.1 over 10, 6, 1 over 100, 7. Now, what does that actually mean? And what it actually means is that what we've done here is that we've taken, we have a value here of 150, 150.67. But here we're showing that this is just 6/10, and this here would be 7/100ths. Okay. The further right we go, if we went on further, we'll then be looking at 1 over 1,000. Okay. etc. But as we move right on, numbers get smaller. Now, please note, for my edification, I'm looking at moving right from the decimal point, which makes the numbers into fractions. Okay, so here we have whole numbers, and here we have decimal point, and here we have our fractions, as I've just said. Okay. Now, our task here is to the decimal point is used to separate whole numbers from fractions. So 150.67 equals 150 plus 6 over 10 plus 7 over 100. Okay. So this number here, 6.6, is actually 6/10. And this here is 7/100. Okay. Now, what we are looking at here now is trying to bring these two to the same denomination. So if we multiply that there by 10, that by 10, let's look at what happened when we multiply that by 10 and that by 10. We are looking to bring this to the same denominator. So what happens is that let me just get my pen. Let me see if I can get a mark on it. Okay. Okay, good. Okay, so we have, when we multiply this by 10, okay, and all I'm going to do here is just multiply that by 10. So 6 times 6, 10 times 6 is 60. And if we multiply 100 by 10, and I'm going to do that by here, let me just bear with me from this side here. Now, exclude my zeros, okay, they're not quite good. But trying to write with this pen on here, it's not everything is cracked up to be. Okay, I'm just saying here that times 10. Okay, so here we have 10 times 6 is 60. We can come, I'm going to come all the way down here to show you that this is what we get is that. Okay. Okay. We then get that. Now we then 10 times 10 is 100, and that comes down all the way down to here. Okay. I'm going to go all the way around, make sure that it's not confusing anything else. So we went all the way around, and that becomes all 100. Okay. Okay, let me go back to my marker again. And now can we change the same marker? Okay, right here. Okay, so 10 times 6 is 60, 10 times 10 is 100. So you can now see that denominator is now the same as that denominator. Therefore, we're now going to add these two together. Therefore, it gives us 60 plus 7 equals 67 over 100. Okay, now we can bring this down to a lower level. Okay, so this answer here now is 150 over as a fraction and of a whole and plus the whole gives us 100 and I hope I got this right in there, 150.67 over 100. Now, can we bring this down any further? And to reduce further, we use the term simplify, okay? So, okay, and that's about the lowest level that we can get it down to, is 67 over 100. Now, if you try to divide 67 by 2, it won't work. By 3, it won't work. Nope, 6 won't work either. So there's no way of bringing this down to any low level, basically. So that will be our unit. So it's 150.67 over 100. Now, if we wanted to make this to a decimal, what we'll now do is bring it to a decimal, and it will be 67 divided by 100. That would then equal so therefore from our figures up here 150.67, you can now see where we got this from. Okay, have I still got my pen? You can now see where we got this from. That would then be equal to, sorry, let me get my rubber. That was atrocious markings there. Okay. Right, so that could be that. That equals 1 5 0 point 6 7. Okay, and now that is where we got our answers from. We started off with a figure, okay, a given figure of 150.67, and that was a figure given just as an example, okay. And that will then give us our, that's how we will then, this will then become 150.67, and this will now equal this, okay. Okay, that's how we got off configuration of numbers. Okay, now I'm only extending these to 15 minutes per time. So let's look at another work example again. Okay, and it says here, clearly states here, work example. Is 2.5 greater than 2.477? Well, let's find out, shall we? Now, is 2.5 greater than 2.477? Solution. We need to write down 2.477, and it's equal to 477 over 1000. Now, if you remember, I told you if we went on any further at this point, you remember when I told you that if we're going over, carry on to 1 over 10, 1 over 100, then we could go carry on to 1 over 1000. That is what's happening down here now, okay? Okay, so that is what's now happening here at 2.477. 2.477 equals 2 and 477 over 1000, okay? Now, we then also need to look into 2.5. So we've dealt with the last number first in this case. We're not going to deal with the first number last in this case. 2.5 equal to 5 over 10 because it is going to be 5 tenths. Okay? Now, so we need to add these two together. And as we bring this level here up to equal the common denominator, this is our common denominator, the top number is our numerator, okay? Numerator, denominator, okay? So as we bring these to be in the same level to 1000, we add a 0 to the 5 to bring it to 100. We then add another 0 to the 5 to bring it to 500 over 1000. So we now know that 2.5 is greater than 477 because 500 over 1000 is greater than 477 over 1000. So our answer then becomes, now actually we should actually be adding this as such, but mind you, sticking to the question, is 2.5 greater than 2.477? And the answer to that is yes. And the answer to that, let's put that in, it is yes, okay? Exclamation mark. Okay. You better let me take that out, of course. That could be confusing. Okay. Let me go back to my number now. Okay. To my pen. Okay. Okay. So we need to stay within the question. Is 2.5 greater than 2.477? Yes, it is, because we have proven it by bringing these numbers to the same equivalent denominator, and we can then see 2.5 is greater than 2.477. We write 2.5 is greater than 2.477. Okay, and notice the arrow direction means greater than, means less than. Okay, and I'm going to stop there for now, and I hope you found this useful. Okay, right, have a good day. We will pick this up again. All right, okay, and we'll start take it up from there. Right, thank you. Have a good day. Bye bye.